And folks, at this time, I'd like to turn the program over to your moderator, Ben Lorica. Hi, Ben.
Thanks, Yas. Hi, I'm Ben Lorica. I'm the Chief Data Scientist at OReilly Media and also the Program Director of Strata plus Hadoop World, and I will be your host for today's webcast. One of the things that we follow closely at OReilly and at Strata plus Hadoop World is the re-emergence of real-time, large-scale real-time processing. To power many of these applications, data stores lie at the heart of many of these applications. So I'm really excited today to have the CEO and co-founder of Mem Sequel, one of the more popular data stores that are used for advanced analytics and real-time analytics applications. So Eric Frankel co-founded Mem Sequel and has been CEO from the start. Before Mem Sequel, Eric worked at Facebook on partnership development. He has worked in various engineering and sales engineering capacities at both consumer and enterprise software startups. Eric is a graduate of Stanford, and in 2012 was named on the Forbes 30 Under 30 list of technology innovators. I will turn the program over to Eric in just a moment, but first let me go over a few housekeeping things to help you get the most out of today's webcast. First, you'll want to open the group chat widget if you haven't already done so. This is where we'll interact with each other during the event and where you'll submit your questions for Eric. Many of you have good insights and experiences to share, so we encourage you to chat freely during the event. However, if you have questions for Eric, please preface them with a capital letter Q, so we'll know that it's for him and we can make sure to see it for our Q&A. You can also open, move, and resize any of the other widgets. If you would like to tweet from the Twitter widget, you'll need to give it permission to access your account. Our hashtag today is Strata Hadoop, all one word, and the Twitter widget will automatically append that to your tweets, so you don't have to. If you have any problems during the event, we encourage you to look at the help widget, which is very comprehensive. If you continue to have problems, post in the chat room, and one of our staff will help you. For choppy audio or stalled visuals, try refreshing your window. We are recording today's webcast, and we will have the archive ready usually in about 48 hours. And at this time, I would like to turn the program to Eric for his presentation. I will come back at the end to moderate our Q&A. Please welcome our speaker, Eric Frankel.
Well, thank you, Ben. It's great to be here with you on today's webinar. I'm excited to be here to be talking about building real-time data pipelines through in-memory architectures. To get started, we can chat about what's in store for this presentation. And it's going to span a variety of topics around in-memory, as well as some new architectures, as well as use cases and even a demonstration. So to kick things off, let's talk about where we see the world going. And we think that the next phase for big data is going real-time. The reason why is that there are certainly more sensors and devices across every use case. Things are more interconnected, and fundamentally users demand more immediate access to data, no slow loads, etc. So we've really focused on taking companies into the real-time phase and providing cost-effective architecture to do so. Principally within the larger enterprises, we see a tendency towards hardware database appliances to power these workloads. But you'll find that these are very expensive. They don't scale. They're more focused on batch processing instead of real-time processing. And they are fundamentally attached to a very expensive SAN. And as we look forward to the next phase of development, we see that a distributed commodity architecture will be able to drive new real-time analytic applications. So that's something at a high level that has really sort of focused us over the last couple of years. And we can now start talking about how to use an in-memory database with some new technologies like Apache Spark and Apache Kafka. So before we jump in, I thought it'd be interesting to take a fresh look at Lambda architectures. On the left, you see that, of course, that a Lambda architecture is comprised of 3 basic tiers. There's a speed tier, a batch tier, and a data serving tier. Now, if we organize that into more of a relational world on the right-hand side, you'll find that we can actually bring it all together in the same system. Within our own approach of a comprehensive architecture, we really believe that the fundamental unit of a business is the transaction, and that everything surrounding that becomes supplementary analytics. So in order to enable those transactions, there's a need for in-memory data stores, which are row-oriented to provide those fast updates that are transactionally oriented. But as you hit the limits of memory, as you stream more and more data in, it becomes really critical to add a column store for analytics on the second axis. This column store is really principally designed for historical data retention. It's a batch layer in its own right, and it's designed, if anything, for fast appends and nothing more. But what's critical is to put an execution engine across both engines to span the entire data spectrum. And that's what we have done with our technology here, is to focus on delivering a holistic approach to a comprehensive architecture. So the Mem Sequel execution engine sits up top. Now, with the Lambda architecture, with the speed tier, etc., you're going to find that there's a traditional Lambda and then our interpretation of a modern Lambda. For a traditional Lambda, you might see Hadoop as the column store of record, or the batch process. If you want to have your speed tier, you might consider Storm or Spark, and serving it would be from Cassandra or HBase. The Mem Sequel Lambda architecture is really predicated around these 2 storage engines. So our batch tier would be the column store. The speed tier would be a combination of Kafka, Spark, and Mem Sequel working together in memory. And then the data serving tier would also be out of memory as an analog to Cassandra or HBase. So we'll focus today on how to design the ideal real-time pipeline using 3 technologies: Apache Kafka, Apache Spark, and Mem Sequel. And we'll jump into what each of those will do. But to bring everyone through a quick primer on each technology, we'll start with Kafka. Kafka is a high-throughput messaging system. You can publish and subscribe to topics within the feed, and you can fundamentally think of it as the centralized data transport for the organization. It's the modern data bus. Apache Spark is a very exciting new technology that is effectively a way to write programs, procedural logic, for data scientists. It's an in-memory execution engine, but it is transient. And fundamentally, it exposes in Scala and Python high-level operators for procedural and programmatic analytics. And of course, it should be noted, it's dramatically faster than MapReduce, being in memory. And then Mem Sequel. Mem Sequel is an in-memory distributed database. It takes care of the durability. It's fully transactional, and it's there to enable real-time and performant applications. So this is how Lambda applies to real-time data pipelines. You can fundamentally see that any data input will be sent into a message queue, where that data could then be forked into 2 separate places: a batch orientation and then down a real-time data path. The transformation tier is then connected with the database, which is then connected with the app, and that fundamentally is a Lambda architecture. Moving on. Once we actually look at some of the specific technologies for this Lambda architecture, you can see how Kafka, Spark, and Mem Sequel slide in together to provide this real-time component. So what we did around that was to build a new product that tied this all together, called Mem Sequel Streamliner. And this is something that lets an end user create a real-time data pipeline in a matter of clicks. So with that, I can introduce actually the Streamliner product itself, which provides one-click deployment of Apache Spark. And it lets you create real-time data pipelines via the interface. And that is the second half around using Apache Kafka. Best of all, this is all open source on GitHub. We really believe that this pipeline approach is very extensible, and that's why it's shared there on our public account. So in terms of how the Streamliner process works, it can start off with basically an empty cluster. What we'll then do is actually deploy the Mem Sequel process onto the cluster itself first. This sets up a in-memory distributed relational database. And then the next step, of course, is to co-locate the Spark processes on the same machines as the Mem Sequel processes. This is done so that you can avoid an extra network hop. Once we have that, it becomes a simple matter of connecting Kafka into the cluster. This is done through a GUI. It takes just, as I mentioned earlier, a few clicks, and you now have an ability to ingest live Kafka streams. So the Streamliner architecture is just the first of many integrated Apache Spark solutions. Mem Sequel can run Apache Spark natively, and this means that Streamliner is just an application that is going through the Spark environment. Streamliner itself is leveraging Spark streaming, but it has built a lot of technology on top of it to make it even more performant. We can take a look at some of the Streamliner detail here. In this particular diagram, you'll see that Streamliner is principally focused as an ETL tool, where you can define your custom extractors, you can perform custom transformations, and then fundamentally load it very quickly into Mem Sequel in memory for real-time serving. So let's go ahead and dive into Streamliner and how it works. What we have here is an ability to look at the extraction phase first. In this case, we have Kafka as an endpoint, and all you have to do is paste in the Kafka URL, the port, and then subsequently subscribe to the Kafka topic, and you now have the first of 3 steps completed. If we move on to the transformations here, you'll find that what we can do is very easily emit or deserialize the JSON object from the Kafka stream. Again, we just define it in the column phase and proceed to the third step, which is the data loading phase. In this case, you just basically define a database name and a database table and hit next, and you now have a live data feed going into your database. Now, one of the interesting things with Streamliner is that it actually uses something called dynamic resource management. What this means is that we've been able to build the Spark environment in such a way where it's more effective to use Streamliner than not use Streamliner because of how we actually access memory. In the first-hand rail without Streamliner, what this shows is that you need a separate Spark worker per pipeline. With Streamliner, you can use the same set of Spark workers to address any pipeline that you want to touch. So this is very important when you have to think about memory consumption because more Spark workers means more memory use. So at this point, we can go and move into some of the real-time use cases and demonstrations of what the technology can do. And I think it's really interesting to see how this is being used in the real world. But we can start off with a fact that there is one architecture for many different applications. And this Lambda architecture is very exciting from that perspective. So we can start off with Comcast. Comcast is a very large media company that has a variety of use cases and applications for real-time analytics. But their principal one was monitoring their real-time Xfinity line. All of the programming and the video health necessitated a real-time pipeline. In this case, we took them from 30 seconds delay down to less than 1 second of latency. Previous to Mem Sequel, they were using Apache, just using Hadoop. And while Hadoop was a fine tool for batch processing, it would take 30 minutes per query to receive something back from Hadoop, an MR. By laying down a real-time data pipeline next to Hadoop, Comcast can react instantaneously to changing conditions in the network and expose that data to more analysts because of our SQL interface. Another example I would say would be Pinterest. Pinterest uses us for real-time trend analytics. And previous to Mem Sequel, they were using Redshift. Redshift was giving them a 24-hour delay in data loading. And that was hugely problematic because it would basically create a full day delay in analyzing anything. What we then did was basically, again, lay down a real-time pipeline around Kafka, Spark, and Mem Sequel, and then use that to provide the basis for real-time analytics. Pinterest is loading a lot of data through Mem Sequel. In this case, Pinterest is pushing almost a gigabyte of data per second, every second of every day. At a daily level, that's almost 72 terabytes of data per day. So just a lot of data flows through the system. The interesting thing about real-time analytics is that it exposes a real need to build applications against the data, not thinking of it as just an Excel report. In this case, what you're seeing here is that the Pinterest data science team built a real-time dashboard to graph all of the recent trending topics per city in the United States. This was something that just exposed the interesting things that were going on within the Pinterest network. And again, only made possible because they had a database that could react and quickly graph what was going on in cities like San Jose, for example, and then finding real-time trend topics. Tapjoy is another example around real-time segmentation. At Tapjoy, they were running over 60,000 queries a second with Mem Sequel. And you can see it's a similar architecture of a real-time message queue with transformation, pushing to a real-time database. But you'll notice that even Tapjoy is using a lot of other conventional database tools like Postgres and Vertica. They're also a big user of Hadoop as well with HDFS. But by using Mem Sequel, they could actually achieve personalization at a level that they hadn't seen before. And they could do that principally because we're just so fast. So having a real-time pipeline is critical and is the second half or component of any Lambda architecture. So I'll now shift over to a more general purpose example called Mem City, which was predicated on showing how a smart city would be able to measure its electrical consumption. I want to preface this with some stats that this particular demo measures a city about the size of Chicago, and that in terms of the total Amazon hardware spend, this is running on only like 3 machines, so only about $2 an hour or so to run this demo. What we can do here is basically show how we're going to build an application very quickly by using Kafka, Spark, and Mem Sequel together. In this first example, you can see that we're going to be taking in an event feed that has a date, time, some measurements, etc. You'll see that Kafka then has to serialize it up, send it over the network, and then what happens is that it's received and into Kafka, where we can basically have Spark connect to the system, and then basically enrich the data, which you see right here. So in this particular instance, inside of the Spark environment here, we actually did a SQL lookup to find that area code. And then we also did a SQL lookup to basically enrich the insert with the type of the kitchen appliance it was. Once we've done that, it's very easy to take the data that you now have manipulated and just automatically save to Mem Sequel with a command called rdd.save to Mem Sequel. This command will then push something directly into a table, as you can see below, which then makes it available now persistently, as well as for high concurrent access. You can start running analytics against this data set, in which case you can do that by, let's say, connecting to a great BI tool like Zoom Data. And this lets you compress development times significantly, simply because you have not had to spend a lot of time coding across the board in separate environments. So this is a very straightforward way of building a real-time data pipeline with just a few simple clicks of a button. So let's talk about building real-time data pipelines and how that dovetails in with building real-time predictive applications. What you can actually achieve with Streamliner is more than ETL. In terms of what we're showing here, it really is a custom transform that you can accomplish in Streamliner. This transform was basically a jar generated from a third-party analytics package like SAS. This particular jar contained a predictive model generated with PMML. And effectively, this predictive model would take an input and outcomes a score. That's the prediction. What we did was take that model, upload it into Mem Sequel, and then IoT data was streamed into the model, scored, and then based on that reading or that measurement, the machine can make the decision to stop drilling, let's say. So predictive analytics is made possible with a combination of real-time data sources, but also predictive models that are built in R or SAS, for example. So in terms of what we can talk about next, definitely excited to share a little bit of background on the company in terms of when we were founded and how we got started. So the company was founded in early 2011. Nikita and I, my co-founder, actually worked at Facebook together, and it was something where we saw all of the early things going on at Facebook around real-time and in-memory processing. But we realized that we wanted to bring this to the enterprise, which is why the company does have a phenomenal enterprise focus, and we're excited to be working with great brands like Comcast, Samsung, Shutterstock, Boeing, and more. At a high level, Mem Sequel was designed for modern software workloads and trends. We are in-memory oriented first. As I mentioned, we do have that column store as well on disk. But the fundamental need was always to take the technology and make it on a distributed platform. The notion of scaling up on a single machine is not as relevant as it would be, let's say, 10 or 15 years ago. But I think also equally importantly was the need to have a fully relational interface. The ability to interact with data using a familiar UI, for example, super critical. And that was done really when everyone thought the world was going to be going to a NoSQL orientation. In early 2011, this was around Mongo and HBase and Cassandra and all of these other technologies. And it was just really functional and important for us to be able to focus on building SQL. We ship software onto a data center or to a cloud. And I think it's really important to emphasize how you have to be flexible and go wherever the application goes. The notion of not being able to take something and run it in a hybrid environment, for example, makes things more difficult, not easier. So for what we see within a span of data, a true spectrum of data, it's that at the very forefront, each transaction is paramount. And then as you get more into analytics, the aggregates themselves become important. If you care about each individual transaction, you want every individual transaction to be persisted. You cannot have any notion of transactional loss, especially if you're talking about financial data, inventory movement, employee status, etc. On the other hand, though, as you get into more high-velocity data sets where you care more about aggregates, you want to basically have an ability to go through repetitive streams of data, whether those are click streams or event data or sensor data, IoT, that sort of thing. But you want to have this ability to be able to get the aggregates quickly. So in terms of where we've been able to focus on for the last couple of years since we've been on the market, this is actually our first year on the Gartner MQ for operational databases. The year before, we were named a Gartner Cool Vendor, and we're very excited to be on this quadrant as one of 4 visionaries. In fact, we're the leading relational database visionary on the chart. So it's a great place for us to have kicked off our first full year of sales, and it's just a reflection that we're doing great things in the marketplace. Similarly, this is also our first year on the Forrester in-memory wave for database platforms. And you can see how close we are within spitting distance, really, of working with some of the leaders in the space like SAP HANA, Oracle, Teria, IBM, Microsoft. So we're the newest vendor on this particular list, and we're also, I think, demonstrating the most potential in terms of our execution. So one of the other things I want to mention about Mem Sequel is that we have a community edition as part of our software. And this is just a quick note on what the Community Edition is. But it's a free forever unlimited scale and capacity edition of the software, and lets a lot of our developers engage with real-time analytics, building predictive models very easily using the Community Edition. So I encourage everyone who wants to learn more, go to the website and take the database for a spin. You can download it with a click of a button. The other thing that I want to note as well is that Mem Sequel published in conjunction with OReilly a book entitled Building Real-Time Data Pipelines. And it's actually more in depth about what was covered today. It talks about the Lambda architecture in detail, but also about actual use cases and how-tos and tips in building real-time data pipelines. So with that, would love to show you guys a demo if you have time. So we can definitely switch on over to my colleague here, Steve Kamina, who will be able to run through a demo of Mem Sequel.
All right, thanks, Eric. 1 second here while we get the screen share set up. Okay. As you can see here, we have a visual of Mem Sequel Ops. Mem Sequel Ops is a management and monitoring tool for Mem Sequel. So just a really quick overview here. You can see that we're running the Enterprise Edition. You can see that we have 12 Mem Sequel nodes running. And for each and every one of these nodes, you see CPU, memory, disk, and network statistics per node. And Mem Sequel is designed to be deployed as a distributed system. So this tool allows you to see the whole system in one view. One really powerful thing about Mem Sequel Ops is we've included the ability to run a basic database speed test within Mem Sequel Ops, which I'll show you now. This test runs for about 30 seconds. And what it does is it creates a very simple table called dbSpeedTest.table with 2 columns, just an ID and a value. And it inserts rows into this table as fast as it possibly can. Simultaneous to the inserts, it actually does a select with a group by, so a non-trivial select with a group by, and shows you a chart of the distribution of the values inside that table. And as you can see, we're inserting about 5 million rows per second with this particular cluster. And this is just commodity machines, VMs running on Amazon. And at the same time, we are querying that entire data set of rows inserted, which is right now about 130 million rows, in under a second. So Mem Sequel gives you, a lot of speed, a lot of throughput with very, very low latency. So as you can see here, 5 million inserts per second with Mem Sequel on 12 machines. The big piece that Eric was talking about in his presentation was Mem Sequel Streamliner. Streamliner is the tool that allows you to build real-time data pipelines leveraging technologies like Spark, Kafka, and Mem Sequel. So as you can see here, there's a Spark tab. There's a Spark tab in Mem Sequel Ops, and it allows you to deploy Spark inline. So I can simply click this button to then deploy Apache Spark within my cluster of machines. So I actually deployed it on a different cluster just to show you that it is one click. And when you click on that, it downloads Spark, installs it in every single machine, and then says everything's good to go. So here's an example. So in this cluster you see here in front of you, we already have Spark installed. So I'm going to click the Spark tab here on the left. As you can see here, I can define new pipelines within this tab. So I'll click New Pipeline. And here I can specify the definition of my real-time data pipeline. There are 3 phases to the pipeline. First is where you take the data from a source, which is called extract. Second is when you transform that data that you captured from the source, which is called transform. And third piece is loading that into Mem Sequel, which is called load. So I'm going to walk through those 3 phases today. So first, I specify the name or some details about the pipeline. So I'll call it whatever, demo. I can give it the description as well. And I can also specify a batch interval, which means how fast do subsequent batches run. As you can see here, the default that is set is 1 second. So we're going to run this pipeline every 1 second, which is very different from ETL pipelines that typically run for hours and they run overnight. In the extract phase, we can specify the source that we want the data to be coming from. In this case, it's Kafka. You can specify your zoo key or quorum here in the format of host port, as well as your Kafka topic. You can then specify the type of transformation that you want. In this case, it's JSON, but I can change it to CSV, or I can even do something custom. And finally, I can specify the load type into Mem Sequel. What's the database name? What's the table name? Is it a row store or column store? And all those features. And as you can see, everything, all the configuration items fit within one dialog. So I just need to fill that up and click Save and Run. So instead of boring you with keyboard clicks, I've already created a sample pipeline over here, which I call demo. And in this pipeline, as you can see here in the definition, I created dummy values. You can specify test as the name of the extract phase. So I created dummy JSON values here. As you can see, I have apple, orange, and banana fruits. My transformation is a simple JSON transform, which grabs that data. And the load phase loads it into a Mem Sequel database called DemoDB with a table called MyTable. And all I'll do is click Start to run this pipeline. Once the pipeline is running, you'll see here in the bottom that the pipeline batches will start updating themselves. And I can even click into any one of these batches if I want. To further that, I can also enable tracing. Once I enable tracing, you'll notice that some of these batches are traced. And by that, we mean that when we click on them, you'll be able to see detailed information about the pipeline. I can see that I've extracted these 3 records, I've transformed these 3 records, and I've loaded them into Mem Sequel. And you can also see the relative time, which is very powerful. Going into the Mem Sequel database, so here, we actually have a Mem Sequel, or a console, a SQL console into the database pulled up. I can show databases. So here you see DemoDB, show tables, my table, and then I can do a select star from my table. And as you can see, I have 240 records because every second it's been pulling records and putting it into the table. And the values are all apples, oranges, and bananas. I can run the same query again, 273, 279. As you can see, we're inserting rows into this table. So that's it for the demo. Just as a quick summary, what we showed is, number 1, Mem Sequel Ops is a management and monitoring tool of Mem Sequel where you can see cluster activity. Number 2, there is a basic speed test included in Mem Sequel Ops to show you how fast the database is. Number 3, you can install Apache Spark in line with Mem Sequel Ops. And number 4, you can create real-time data pipelines that run in under a second and monitor and manage them through this interface. And with that, I'll turn it back to Eric.
Great. Well, thank you, Steve. And Ben, would like to turn it over to you. Happy to move on to any sort of Q&A.
Sure, yeah. Some good questions from the audience. I'll start off with kind of just general questions about Mem Sequel. First of all, you talked a lot about in-memory, but someone is asking how big can a database be in Mem Sequel in terms of size? Can you go
a great question.
Few terabytes, or what's the typical?
So we actually see a lot of our customers run terabytes in memory, and then get into hundreds of terabytes of data on disk in a column store. So because we have a lot of compression available in our system in the column store, it's very easy to get 4 or 5x compression ratios. So we can definitely span, I would say, gigabytes to terabytes in memory. And then if you think about the column store on disk, it'd be terabytes to petabytes.
So in terms of so someone is asking about SQL support. Is it full SQL support? Do you support stored procedures and UDS?
It's a great question. So we support full ANSI SQL, and we actually have another version coming out where we will be adding more advanced features like UDS and UDAs. Stored procedures are something that we don't really believe in. They are just, in our view, like not the right way to be building applications and working with databases. But we're well past SQL 92 and on to SQL 99.
Yeah. No, I'm with you with the stored procedures. So when does Mem Sequel persist data to disk, is it as a row or column store?
It can be both, actually. So on the row store, when we persist to disk, it's through a transaction log. And because we don't have to write a lot of other things around like locks or indexes to disk, we rebuild those in memory, our transaction log is pretty skinny relative to a disk-based transaction log. So even when we're writing sequentially on that side of the house, it's very, very fast. And we've never seen any sort of issues at all with that type of setup. We do have a transaction buffer so that if you do basically fill that up in memory, we will ensure everything gets flushed back to disk, but that's user tunable. And then, yeah, you can load and stream directly into the column store as well for total persistence when you just want to append the data.
So maybe Eric, turn back to your slide on Streamliner. Lots of questions about Streamliner, so we can stare at it.
Sure.
And the question.
Sounds good.
Yeah, so I guess, first of all, just to briefly summarize, because you went over this fast, Streamliner adds exactly what? So what's the before and after in terms of a diagram like this?
Sure. The before would be something more around the resource management, where folks would have to set up their own Spark workers, their own pipelines, connecting, doing all the hand stitching of the code from Kafka to Spark, and then having to transform a Spark RDD to someplace else. So it really would be a lot of delay in actually just doing basic, hookups between these technologies. And what Streamliner does is it really simplifies it to, as you guys saw, a few clicks of a button.
I see. So one of the questions about Streamliner is your usage of Spark streaming.
Yes.
Are you using standard Apache Spark without modifications?
That's correct. So we don't believe in actually making changes to Apache Spark if they don't go into the main Apache source tree. So everything that we use with Apache Spark is the latest version, and it's vanilla Apache Spark.
So what were you run? So do you run on standalone or versus Yarn, Mesos?
Right now, this is running standalone. It's using our own bootstrapping and instrumentation for the cluster. But you can certainly run us with Mesos, for example. We're actually very good partners with the folks at Mesosphere and have an integration point with them. So Mem Sequel runs great with that as a substrate, and Yarn as well.
So with Streamliner, does Spark streaming play a role in pre-calculating aggregate analytics, or is it purely a means to transform Kafka records and then insert into Mem Sequel?
At this point, definitely the latter, where it's just a means of transformation. You do have the Spark processes there, so you could do some custom transforms for sure. But in terms of what Streamliner is today, it is about basically very fast transformation.
So by the way, I imagine the motivation for Streamliner, you probably had a lot of customers asking you for a tool like this. Is that correct?
Yeah, I mean, we saw a lot of folks that were needing to get more and more types of data into the system, whether it's bin logs or direct connects to other databases. Kafka as a streaming real-time message queue seemed like the obvious choice to start with first.
So a question about the demo, because you talked a little bit about the open source edition. So what part of the demo was kind of the enterprise-only features?
That's a great question.
Yeah, I can take that.
Steven can answer that, sure.
Yeah, in the demo, the Mem Sequel, so there's a difference between community edition and open source, right? The Apache Spark ecosystem is open source. So as Eric mentioned, when we're downloading Apache Spark and hooking that into our system, that whole piece is open source, and users can do that for themselves by going into the Mem Sequel Streamliner repository. The Mem Sequel Ops user interface that you see there, that's available for both Mem Sequel community and enterprise users. So that means if I had a community edition of Mem Sequel Ops, although it is closed source, it is free, and I can use that with the open source components of Streamliner. Does that make sense?
Yes.
Okay.
So kind of a question about how you guys do streaming analytics. So an attendee is asking, so much of real-time models allow you to do analytics before landing data in a database. So Mem Sequel appears to require the data is in the database before processing. Is that correct?
Oh, I see. Generally, it depends on where you want to what you want to do with the data. If it's high-value data, generally you want to store it first, and that means committing it to a database. Spark is a place where you can basically apply certain transformation, but it's not a place to store data permanently. It's temporary, and it's transient. It's going to go someplace else. So we generally see Mem Sequel providing that transactional semantics into the equation there.
And to add to that, sorry, the demo or the slides that Eric showed earlier about enriching with PMML information, which was one of the real-time streaming use cases. The computation of those statistical models could be done or is done in this demo, like outside of the database. So actually, as data is coming in, we can enrich that with data that's processed elsewhere and then produce more richer charts that users can then see when they query Mem Sequel. So users can do a combination, yeah.
Yeah, now that you mention it, so actually that Mem City use case example where you did SQL lookups. So the SQL lookup seems to be a common thing in real-time applications, right? But
right.
Now you can actually enrich it with these models from the outside that maybe use PMML, maybe use something else, right? So you can start doing maybe even predictive analytics.
Absolutely. That's one of those examples that we had with the PMML jar. But even in this particular demo, where we're looking at sort of enriching the data, that's done via SQL lookup. So even in your programmatic environment in Spark, you can be doing using a declarative interface like Mem Sequel to find data. So that's really exciting.
So what's next in terms of what are the major things that you think Mem Sequel users should look out for, let's say, in the next 6 to 12 months?
I think the notion of building predictive applications is very exciting because it's basically taking the data scientist out of the back office and putting the model in the front office. If the model can score or respond to real-time data, suddenly that model itself is dramatically more valuable because it actually can play a part in running the business more effectively. So predictive applications and analytics around those predictive models, I think, is very exciting for the next year.
So I think I know the answer to this, but I'll let you guys answer it. So if it's in memory, what happens when the system crashes? Is all data lost?
Got it. The answer would be no. So we're doing a continuous transactional write to disk in the background for that transaction log. And in addition, if you're running the enterprise edition at least, you can store the data in 2 separate places on the cluster. in other words, on 2 separate machines. So even if you lose one machine, you have not lost any data from the cluster itself.
Speaking of which, so for someone's asking for transaction log durability, do you take an approach like Couchbase that replicates in memory before hacking the client?
So we actually don't have to replicate in memory because the data is resident there already. We can just basically do a streaming pass-through, and it writes it to disk in a transactional fashion with periodic checkpoints, or snapshots, I should say. Our transaction log is continuous, and you can actually tune the buffer on that individual machine from 0, which would basically turn the system into a disk bottleneck database, all the way up to an arbitrary number of your selection, which just is the number of megabytes you want to hold in the buffer.
So this is more of me asking you guys, but what's your take on this whole kind of emergence of hybrid systems, meaning systems that can do multiple things? In your case, maybe a little bit of analytics and transaction at the same time. So I think the idea is that in a distributed computing environment, people want to simplify their stack, right? So running multiple systems, specializing in different workloads adds complexity.
I mean, I would definitely agree with that. I mean, from a database perspective, we actually see more and more technologies focused on what we describe as a multi-model approach to the world. So the notion of having a NoSQL database and then a SQL database and then a document database, that all becomes a lot of overhead. And you're finding that a lot of transactional relational database players like Mem Sequel have added JSON, which is typically a NoSQL feature. And a lot of the NoSQL vendors have tried to incorporate more SQL-like capabilities into their system. So it comes at it from both ways. But to put an example of multimodal use cases, the fact that Mem Sequel has a JSON data type, for example, is one reflection. That we have geospatial data types as well. So along those lines, that you want to co-locate machine learning processes with transformation tools. That's certainly there from a hardware spend perspective. But we tend to look at the world going towards more multi-model and not less.
So historically, Eric, the company came at it from much more of making sure transactions were done right?
When we work with RealTime,
then the analytic capability came after. Am I stating it correctly?
I mean, in a few words, yes. I mean, we built the row store first, and then the column store on disk next. But we always had this focus on using the distributed nature of the cluster for fast computation. So our optimizer has gotten better with each release, and we're able to run more and more complex analytics as a result.
Right, but I think you guys did a lot of hard work just making sure transactions were correct.
Oh yes, no, building a transaction engine technology is like 10 times more difficult than building a column store technology. So we put a lot of work into the row store, the last 4.5 years.
So an attendee is asking, and I think I know the answer to this, but in your example, you use SAS for the analytics, but you could have used a Spark machine learning algorithm or even MLlib, right? Yeah,
absolutely.
Yeah. And I guess we can close with this question, but what language is Mem Sequel written in?
It's written entirely in C++.
Okay, yeah. Get out of the JVM. All right, so with that, I think this concludes today's webcast.